All right, this video is for you Mopar guys, old school stuff, alternator with a external voltage regulator. We're gonna do some checks on this system to show you how to identify a faulty alternator with just using a test light. Stuck on the side of the road, something happens, you got a test light with you, which is exactly the scenario that I had yesterday. I'm driving the truck, doing one of these, and, you know, just playing around, well, I threw my power steering belt off. And, of course, you notice that right away, steering gets tight. I pull over, pop the hood. I noticed this time, because it happened twice, I didn't tighten it enough either, but this time the belt went through the alternator belt and rolled the belt on the alternator. But I noticed that I wasn't charging anymore after that. So I did a visual inspection. Basic stuff, right? Let's look. So I thought, you know, with this belt on the alternator here being like rolled up and like up in here, that it just wasn't spinning fast enough. So I got it home, put the belt back on, and I'm still not charging, and I'm like wondering why. So well, maybe the belt came up and hit one of my plugs back here. So I checked the main battery plug right there. I checked this battery feed for the field rotor for one of the brushes here, and then I checked the top one up here, this white one, and they're all in place. I even looked back here at my voltage regulator, which is bolted on the firewall back here. Very common to have a ground issue, especially when it's loose like mine. Can you see the movement in that? It really needs to be bolted better than that. It has a good ground though, but I saw nothing. Let me show you my battery voltage. Let's go inside real quick. All right, so for battery voltage, we're just gonna use my Terminator display. This has a Terminator EFI system in it, and I have a nice battery voltage display. You see it right there, it's 12.3. This is a cold start, so let's start it. Yeah, as you can see, it is not charging. We're at battery voltage of 12.1, okay? All right, so now we gotta do some checks, right? Visual inspection, no good. What happened? What happened here? Let's do the checks. I was not kidding whenever I said I have a test light with me. So here's the checks that I did. Test light to battery ground. Touch battery positive at night. Main battery post. It's lit. That's check one. Second check. Positive brush. Want it to be lit. And then this is going to be the negative brush that's controlled by the voltage regulator. Got nothing on that. Okay? So next step, that's telling me that that circuit probably has a full ground. I'm sorry for the noise here. To prove that the regulator's grounding that all the way. Test light, battery positive. Now, when I touch the ground, right, light's gonna light. Is that circuit grounded? What? That is a full ground on that. You can also do this. Disconnect the wire, touch your test light. That is lit. That voltage regulator is doing its job. It's grounding this alternator, trying to create a strong magnetic field, and it cannot. This last step isn't really needed. That was enough. That's enough info. I have battery feed on the main cable. I have ignition feed on the field wire that goes to the rotor. I'll have my son right now pulling an image. What you're looking at, this red wire, is the feed from the ignition. Feeds in through one of the brushes on the rotor, and then runs through the winding, and then comes out on this other pin. This white wire is going to be this pin right here that's coming out of the alternator is your negative brush that gets grounded by the voltage regulator on this white wire. That regulator up on the firewall will pulse the ground. It'll control the rotor current flow, which controls rotor field strength and controls the output of this alternator. Now check this out. What could damage this alternator from a belt running through? And what I think happened the front face of this right here. And you see how much movement is in this. I believe that damaged one of the brushes on the alternator itself. I think that's what happened. But this test, let me turn the key on. Okay, key in the run position. I should have power on this red wire. Yeah, I do. And what should be happening is power's going into the positive brush, wrapping through the rotor windings, coming out on the negative, looking for a ground. The rotor is very, very low resistance. You're talking somewhere in the 2 to 20 ohm range. This should light almost as bright on this pin as on this side, with it not running. With power coming in here on the positive brush, there should look like power. It's not. It's really after a winding waiting to be grounded, but that should be lit right there. And that's what has caused this. When that belt came through, it damaged the brushes and is now no longer making contact on that either positive or negative brush. That should be lit right now. On a good alternator, on one of these, that should be lit. Maybe not quite as bright as the positive, because you'll drop some voltage in the rotor winding. Probably not much. If this is only a 2 ohm rotor, you'd never see it. It would look just as bright as the positive. But that's kind of a final that says, hey, yeah, you got something bad in here. This test really isn't needed. The text that I showed you, making sure you have a good ground on the field circuit, making sure you have a good feed coming in on the positive brush, and then making sure you have battery voltage on your main feed to the back of the alternator. All of that stuff was good enough. It's like, man, how did that get damaged? And that's the only explanation I have, is this power steering belt, when it threw off, it got wrapped up in there and just put a lot of tension on this pulley. And yeah. So yeah, I'll show you that test again with the new alternator, and we'll redo the checks, and I'll show you how to full field this as a final piece to this. I may actually end up taking this apart and see what's damaged in it, but I got to do measurements and find the right part now. And yeah, so hopefully that helps one of you. It will help especially with the follow-up coming up here, which will probably be a week for me, but it'll be for you guys right now. Okay, so we're back. I got to fill you guys in on some things that we did. We confirmed faulty alternator, and what I did next is I took it apart, and what we found was what we suspected, which was a broken wire to one of the field terminals or brush contacts. It wasn't actually a brush contact, it was on the slip ring itself on the rotor, which essentially the brush connects to, that had been damaged. So something went through this alternator to pull this thing apart. You can see in my hand, I'm actually holding like a piece of solder that it just ripped that wire off of the rotor and the slip ring, which essentially, again, is connected to the brush. I thought initially, based on the way the brushes were, that with the play in the pulley that it ripped a brush itself off, but you can see the layout of the brushes, like one's facing downward and the other's facing sideways, and just within that design, that didn't happen. Something went through, piece of the belt went through and ripped that off. I did solder it back together, and I was successful in doing so. And then I really was not able to find a bearing assembly that I needed to take care of that play. It was maybe $30, $35 for a bearing assembly. And what I ended up doing is getting a whole remanufactured alternator from Summit for like $60. I did, however, want to prove before putting the alternator in that my repair would work. And so here's a clip of me running it late, putting the alternator back together, and you can see, well, play the clip. Okay, moment of truth, guys. I have it all back together. We're going to start it, see if we have charging voltage. So you saw it was charging. The reason I didn't leave it there is the bearing was making noise and the play was there. I threw the belt again. I'm like, all right, I'm not fooling around with this, you know. And I mentioned finding a bearing assembly, reman alternator. I just went reman alternator, okay? So we now have a remanufactured alternator in here, and I want to redo some of the checks for you guys that we did before to show you what it should look like, and then also add some variables in here, such as what do you do with an overcharge problem? What do you do if it's not charging at all and you have different results? And then also show you that pulse width modulated signal on a graphing meter so you can just get a good visual of what we're talking about. But I really want to stick with the rest of these checks with the test light, because a lot of you guys that drive these old school Mopars, maybe that's all you have. And so really that's kind of who my target audience is for this, is the guys that have these older systems and don't have all the fancy electronic equipment, test equipment that I do, sticking with the test light for the most part. All right, let's get started. All right, so again, we'll go test light to ground, and keeping in mind how basic this system is. There's no computer controls or anything like that. We're only talking about a 2-wire voltage regulator way back there on the firewall. That's it. So as soon as you turn the key on, that voltage regulator is going to come to life, and it's actually going to start grounding this rotor field circuit, which is really another reason that on our tins, we don't want to leave the key on to listen to the radio. Not only do you have your rotor of your alternator being magnetized, energized, amperage being drawn from the battery, creating heat and, you know, killing your battery, but also our old school ignition systems, it's the same thing. We're grounding the ignition coil all the time with the ballast ignition systems that these use. So you're talking a lot of current there too. Just another reason not to leave your key on our old Mopars. Now for mine, I'm running a Holley Sniper EFI ignition coil and module, and I don't have that issue anymore key on. However, watch this. I'm gonna turn the key on, you'll see. Aside from, you know, checking the main battery post, which we've discussed in part 1, which is, can't even get to it, which is that guy. We're not focused on the battery post 1, but if I forget, when you're checking these alternators and you're worried about a voltage drop on your battery post, you really don't want to use a test light here, because the only thing I can do is look at that light brightness and then come over to the battery and look at the brightness here and compare the two. But you really want to do a voltage drop test on that main cable if you're worried about that. And you really want to do that one with the engine running, because you want the circuit to be loaded, and they should be equal. If you have 12.6 volts, say it's not charging, you have 12.6 here, you also want to have 12.6 on the battery post. And that's really the test you want to do. You'd want the engine running for that one. But we're not dealing with the main feed. We're talking about field circuit for this whole video. So initial positive brush. All right. Want to make sure that that's lit. And then my negative brush, you're going to see something different here now. My negative field terminal. Notice it's dim. It wasn't lit at all before. Why is it dim? Well, it's dim because that voltage regulator that's back there on the firewall is actually grounding, not fully, but it's grounding that circuit right now. So right now my rotor is making a magnetic field. I wonder if I could prove that, just like put a piece of metal in there and have it stick to the alternator itself. It might actually do that. That would be kind of cool, but it's inside behind the stator, so it may not. Should I grab something just to see if we can make it stick?
Just to see.
Just to see. Keys on.
Okay.
It should drop. It should. That was pretty cool. So magnetism, yeah. The point of that exercise was just that rotor field is magnetized just with the key on, and that's what's going on with my test light. That's why my test light was dim, so it's off right now. Watch, I'll turn the key on. Test light's dim. Again, why we don't want to leave our keys on when we're listening to our radio, right? Turn the key in the accessory position
because you're just, that's like probably 2, 3, 4 amps of current, maybe 5 amps of current. It's a lot just going through that. Okay, disconnecting my negative field terminal. You see the arc when I disconnected it? Okay, that's just current flow. Now my test light is going to be bright here. That's what we were talking about before. That was our main diagnostic that said our open was inside of here, was our lighting on the positive field terminal and our light not lighting on the disconnected negative field terminal. Open inside here for sure. You can see we don't have an open anymore. We have full continuity. And again, the brightness of that bulb here on this test will be dictated really by two things. And number one would be the rotor itself and the resistance of that rotor. If it's a low ohm coil, there's not going to be much of a voltage drop at all across it because my test light has a lot more resistance than the rotor. And that's really going to look like a battery positive source. Like the brightness of that, can you see a difference between that
Super bright.
and this? Is it any brighter? Maybe just a tiny bit brighter, right? But if I was checking a different circuit that had a higher ohm coil, my light would be much dimmer. So just some lessons in there on that. But the second one that's a factor, that is a little bit dimmer. The second one that's a factor would be the light itself that you're using. And I want to, again, tell you guys, if I haven't already, for all the checks that we're doing, we want to use an incandescent test light. This looks like an LED test light. It's not. It's just a red bulb. It's a regular filament style, old school incandescent test light for everything we're doing here. Okay? LEDs will get you in trouble when it comes to troubleshooting, especially on this kind of circuit. All right. So one of the beautiful things with our charging systems and the way these are and how basic they are, a lot of our checks that we can do for this, we do not need to do running. This is not typical. Our cars today, we need to be running our systems to check a charging system where this one's active right now. And so now that I realize that, whenever I guide you guys in any of the comments or questions that I get on this system, I'm gonna have you do key on test. There's no reason to have the belt spinning, the fan in the way, my test light getting wrapped around the fan or hitting my hands off of that. I mean, I can just do it right here. So the next one's gonna be, if your alternator's not charging, you're gonna do these same checks. And one of the primary ones after you have verified that your battery post has a power feed, right? And this one you would want to do running, battery power feed to the post stuff. And then you check your ignition feed to your positive field. This one is going to be the one we're going to do for the rest of our checks. What do you do in this case? I'm just kind of back probing this guy. I think, yeah, okay, my key's still on. What do you do if this is really bright here? It shouldn't be bright. It should be dim, telling you that you have field control going on. What will you do if this is plugged in and you see a bright light like that? What that's telling you is your voltage regulator is not functioning properly. It's not doing its job. It should be grounding this circuit like that, dim light. What do you do if it's bright? It's either going to be an open in this negative field wire from here back to the regulator itself, which would be uncommon unless you got little mice or bad wiring on your vehicle, but an open in that wire, or a regulator that is bad and not functioning, or a regulator ground. This grounds on the housing. Remember I talked about how I didn't like my housing being loose. This grounds actually on the housing itself. One more would be the feed to the regulator, right? There's two wires here. Kind of pull them up so you can see them. You'd want to make sure you have a 12 volt feed. This is the same 12 volt feed that goes to the regulator as this 12 volt feed on my positive field circuit. They share the same splice. They both get powered at the same time. So you want to make sure you have 12 volts on this wire. So you'd want your test light to light on this wire. Let me back up, make sure we're all following. Starting here. If this is bright, right here, that means your regulator is not grounding the circuit. So open in the field wire between here and here, a no power feed to the regulator here, because it needs power to start working, a no ground on the housing, or an open in the negative field wire, right from here to here. So I said that already twice. Open field wire, no power, bad ground. What can you do? Take your test light, the circuit's energized right now. Just touch it right there on the housing. What's gonna happen if this housing does not have a ground? It's gonna look the same as me unplugging this positive terminal here. There's no ground now, right? What's my light do? It lights. What's this gonna look like plugged in here if I take my ground away? This housing is actually gonna light your test light to battery ground. I could show you that, but I would need to unbolt it to do that. And I don't wanna do that because my bolts are already, can you see the silver bigger bolt here?
Kind of, yeah.
And the crappier, smaller bolt there? It's already stripped out. It's loose because my firewall is hogged out where the bolts are, and I really need to do something about that. And I'm not touching it because if I do, then it's not gonna be grounded anymore. And that would suck, right? But watch this. I'm gonna leave my light here, okay? I'm gonna create an open between, which is me unplugging that back there. Watch what my light does when I unplug this back here, okay? Just gonna reach back, unplug this regulator. There you go. What do we see? Bright light. So how would you recognize an open from here to there? Well, you can unplug it like I just did. Okay. Take your same test light, go to the same wire. What should it do? This is the same negative field wire. It should light all the way over here. If it lights there, what's that tell us about the wire in between? Wire's good. So then you want to make sure you have a 12 volt feed coming in. I would suggest your 12 volt feed here, you do this plugged in, not unplugged. It's not as loaded, unplugged. We can have a voltage drop. We want to do that one plugged in. But this one, there's no open between. So your last two checks, make sure you got 12 volts on your red wire, and then plugged in, we're going to check our ground. And plugged in is when we want to check our feed too. Plugged in. Now what do? A lot of the guys are like, pull it off, clean up your ground. No. Why would you do that when you don't even know if that's your problem? Just check it. Test light, touch on the housing. It's gonna light, I promise. It'll light if that ground is bad. And then the last check again would be your positive. In this case, you would have to pierce to check that. I'm recommending you do it. Seal up the little tiny hole when you're done. Don't put a gaping hole in it. Why do we want it plugged in? Loaded circuit. You want a loaded circuit. Unplugged, my test light only puts 180 milliamps of a load on that. There's more of a load on that plugged in. You want test light load, circuit load when you're checking them. I have fancy tools for this kind of thing. This is a little kind of bed of nails. Leaves little tiny holes. Then I always use liquid tape when I'm done. By the way, this is called Phil's electrical probe. The best freaking piercing tool on the market. Watch this. The little hook the wire, drop it, done. Tiny holes, fix them when you're done. But here's your feed. I can go right on the side. Wait, let me move my hands out of the way so you see the light. How's my power feed to my voltage regulator? It's good, right? Plugged in, key on. I don't need the car running. I don't need the truck running. That's your check there. I showed you the check on your negative field wire, and I talked about the check on the housing itself. I really want to unbolt my regulator to prove to you guys that that housing will light. You know, if you want to, you can always switch your test light to battery positive, which I just did. Did you catch that? So when I touch ground, my light lights. Then with your test light on battery positive, come back and touch on the housing. It should light. But it will look like that on ground. With your test light to ground, with the key on loaded circuit, key's got to be on. If that ground is bad, that light will light. With my test light connected to ground, it will light. Right now my test light's connected to battery positive, just an alternate way of doing it. I think last thing I want to show you, just what that control actually looks like. I guess the only other one I didn't discuss before I show you the pulse width modulated signal. What do you do if it's overcharging? What's an overcharge look like? An overcharge is going to be when that field terminal, that negative field terminal, is grounded all the time. So really there's two things that you can do for that. One, you got a voltmeter on the battery, you're running the car and you see 17, 18, 19 volts, right? You're probably burning out bulbs and bad stuff. Reach over, unplug the voltage regulator. With the voltage regulator unplugged, if your charging voltage drops down to battery voltage, it's your regulator that's doing it. If it stays high, then your negative field wire is touching ground on your harness somewhere. It's a really important test. Before you throw a regulator at it, make sure. It's that simple. Unplug it. Now, before you change the regulator for an overcharge for a fully grounded condition, let's say you unplug it and it comes down to battery voltage, make sure that your positive wire going in to the regulator, that's this red one, make sure you don't have a voltage drop on this wire. Because if this wire is lower voltage than the battery, that's what it's using to determine how long to ground the circuit. It's actually monitoring voltage on the red wire. So let's say, for example, it's 14 volts, but you're only reading 10, or let's say it's battery voltage of 12.6 and you're reading like 8 volts on this. What's that regulator going to do with 8 volts? It's going to try to bring that 8 volts, well, engine running now. What's it going to do? Battery voltage is 12.6, but we want to be at 14. What's it going to do? It's going to try to get up to 14, and if the voltage is low on that red wire, it's going to do that. So you want to make sure that this is equal to battery voltage before you change the regulator, because you could have a voltage drop problem on that red wire, cause an overcharge condition. Okay? Last piece, just want to show you guys what this actually looks like. Just using an old school graphing multimeter. I'm actually going to show it to you with the test light too. Put the test light in here. Just going to clip that to the end of my test light. And then find a, can I reach? Barely. I want to see something here too. Before I show this, let me make sure I'm not speaking incorrectly on what I'm seeing, because I'm seeing a flat line here that I didn't expect. Well, I don't even have a voltage reading there for you on this scale, but it's like 14 at the top. There's 0 down here, and this is probably about 4 volts. And I just want to make sure my test light's not interfering with what we're seeing here, because it might a little bit. Let me get the test light out of the picture. Just go right to this. Okay, it wasn't. I thought it would be pulsing this. It's not. It's holding it at a, here, I'll get you a, let me change scales. Go ahead, you focus on that. Get you a number here. Just what you would see voltage wise. I guessed it was about 4 volts. So 4.2, a no ground would be battery voltage. A full ground would be 0. And that really shows you why my test light was dim. So it's not pulsing it right now, it's just kind of holding it. It's holding it at that level, trying to bring voltage up on the alternator. Interesting to see if it goes any lower than 4.2 on a quote full field, which is a full ground, which would be when we're trying to bring battery voltage up. Because it's a dumb system, it doesn't know that we're not running. So that probably is as low as it's gonna go, is my guess. Like that's as low as it's gonna go. I missed something too. Scenario is you got a bright test light here on the negative field wire where we addressed like all the variables of it not charging in the regulator itself, right? One of the things you can do to prove the alternator works fine, take the field terminal off and ground that pin momentarily. Don't do it for a long time. Immediately what will happen, engine running, you'll start hearing this alternator sing and you'll start seeing charging voltage climb. Don't hold it there because you can produce a lot of voltage with these without a regulator. That's considered a quote full field. To full field an alternator, we're bypassing the regulator, and in this case, it's a ground side switch circuit. We're just grounding that pin. You can do that with a jumper wire. Don't throw an alternator in it when it's not charging. Do your checks. These are easy checks. Bright light bulb there, it's not being grounded. Ground it. Check it. Make sure it charges. Then do the rest of your checks we talked about over at the regulator. So I missed that piece. There's so many variables. I wish I could talk about them all in one video, and it makes it hard to watch when I do this. It probably is already hard to watch, but for some of you, what I'm covering here is very important, and there'll be pieces of this video that you'll want to pause and you're going to want to look at and study because we've added drawings and things to really help you guys with these. But that's with my test light in there, so my test light is kind of having a little bit of a factor on that of 4.2. Now we're at 3.9. So what I'm going to do now is start it. What I want to do, so what we're going to see is, we'll call 4 volts as low as we're going to see. What we're going to see is as my system voltage climbs, then it's going to start pulsing. And we're going to see my test light is going to get brighter, and we're going to see the meter start to pulse. This has a roller valve train in it, so you gotta ignore the little bit of tapping. It says lifter bars. But watch it. You see the light's already a little bit brighter. There was a pulse, starting to pulse. There's your pulse. Look at the light now. Some of that is my light not making good contact, maybe. Yeah. That's engine running stuff. Which definitely changes, doesn't it? Like if you were doing the checks I showed you as far as like bright light, dim light kind of stuff, if you remember, especially in a no charge situation, you may not even be able to recognize that. That's why the key on testing is really important for what I showed you. What's actually happening here, change my scales, there's your pulse width modulated signal. And that's pulling down, like that line right there is 0 volts. That little dark spot on the meter, that's 0 volts. And that's battery voltage up top. The pulse signal. You can see some kind of flickering in the test light a little bit, but it's such a fast signal that really the light never has a chance to go out. That's why it's not pulsing. That's why you really can't see the pulse. Tell me when that says 1 second. Is that 1 second? So look how many pulses are happening in 1 second time frame. You'll never see that on that light. So fast. But that changes some things, doesn't it? That changes some things within your troubleshooting that I just gave you guys on why I want you to troubleshoot this engine off. Last shot of these two. Right? Dim light shouldn't be bright right now. and about 4 volts. If you're measuring that with a voltmeter, you're gonna see about 4 volts on that. So that's what it does whenever it is engine off. There's some smart electronic circuitry within there that it's not pulling all the way to ground, but we can see when it's pulsing, it's pulling almost all the way to ground. Of course, we have the neighbor running a weed whacker right now at the end of this. Yes, but there are variables upon variables when it comes to troubleshooting, depending on the tool you're using, depending on the conditions you pick to do it, and depending on if you're unplugged or plugged in. All of that stuff I'll try to guide you guys through. If you have a Mopar system like this and you have a charging problem, I can guide you to specific parts of the video and say, here's the check you want to do and why. But I think this is good enough of a foundational video for everyone that owns one of these systems that it will be really helpful. So I think I'm done. I think that's about it. There's a lot more we could talk about: current flow, the actual slip ring, the rotor, how much resistance it has. I don't think it's necessary for this. I think that covers the main points I wanted to cover. And I hope you guys like that one. A problem with my truck became an advantage for the rest of us. So thank you guys for joining us. We'll see you next time. Oh, last thing I want to remind you, I also have for our tin grill, for our Mopar systems, the ballast ignition system troubleshooting. I have a whole video on that. It's doing really well. A lot of people like it. It is very easy to follow. So I'll put a link here at the end of this one for that video. Make sure you watch that one too. Thank you guys. See you next time.
Sounded like a Donald Trump statement, like it's doing really well. Everybody loves the video.
Yeah.
They all said it was the best video.